Okay, now we're going to talk a little bit about direction. We talked about magnitude a lot and components. We're going to look at the direction of a vector. And so I just started off with an example like this. If you can see this example here, it basically says that there's a vector starting at 2, 3 and ending at 5, 4. Okay, so starting at 2, 3, ending at 5, 4. We can see it's kind of moving up and to the right, but we don't say up and to the right. We need more of an accurate description of it. So what we do in math is we come up with a reference point. Our reference point will always be the positive direction of the x-axis. And again, to not confuse you more, but what I'm going to do here is I'm going to make a little tiny imaginary axis right here. Okay, so like here's the y, here's the x. Okay, a little imaginary axis. Well, you can see if I continue this horizontal one, there's a little angle right here. Okay, I'll call that little x right there. There's my little angle right there. Okay, it's going up that way from the positive x-axis. This is my reference point. So in other words, wherever this is, okay, my reference point here will always be from the positive, and it's always going counterclockwise. Okay, it's always going counterclockwise. So in other words, if I have a graph here and it starts from here, it always goes counterclockwise. So up to here, just to remind you, this is up to here is 90 degrees. This is 180 degrees. This is 270 degrees. And of course, if it went all the way around, it would be 360. Okay, so 90, 180, 270, and 360. Looking at this shape here, we can see I'm going to enlarge this here and just say, well, here's my vector. It goes from 2, 3 to 5, 4. So in other words, it goes a distance over here of 3. We can see it went from 2 to 5, so that's 3. From 3 to 4, it only went up by 1. Okay, I can get the length of this very quickly. It'll be the square root of 1 squared plus 3 squared, which equals 10 squared. Okay, or square root of 10. Which equals square root of 10. So when I do this one here, I want to look for this angle, that's x. That's the one I drew here, and it's always going counterclockwise from the positive x. Remember, this is kind of the little scale I did here, the little axis, and so it's going up this way. How do I get x? I'm going to use these numbers, not what I figured out, not the hypotenuse. I'm always going to use the components. Okay, and again, if I wrote this in component form, it would be 3, 1. Okay, but for this one here, what I'm going to do is I know I can use tangent to figure out this. And so what I'm going to say is I'm going to say, well, the tangent of x, the tan of that angle, has to be equal to opposite over the adjacent. So it's equal to 1/3. In order to find x, I have to use inverse tan of 1 divided by 3. Sorry, my marker smudged there. This is 1 divided by 3. And so if I go in my calculator, here, and I'm going to go second function tan of 1 divided by 3, I get, it's around 18.4 degrees. Okay, so that angle right there, we could tell somebody where you're going to, maybe this is the direction they're moving in, and you say you're going to move root 10 meters and at 18.4 degrees. They know exactly where to head. Okay. It becomes a little more challenging, okay, if we don't have it going into the first quadrant. So I'm going to show you another one here. If it's not going into the first quadrant, let's say we have an axis like this, again, and I'm going to just start this one here. Let's say it starts at 0, 3, and it goes up to right here. Let's say it goes, here's my vector, starts at 0, 3, and it goes up to 5, or pardon me, that's negative 2, 5. Okay, so up to negative 2, 5. In order to do this one, here's how I have to look at it. If I did my imaginary axes again, okay, right from the starting point, this is going to go straight down the y-axis. So here and here, we can see that my angle from the positive is all the way there. Okay, it's no longer just this one here from the positive x-axis. So it's actually counterclockwise. It goes beyond 90 degrees, this thing. In fact, if it went straight this way, it would be 180. Okay, and so this one here, first thing I'm going to do is I'm going to figure out what its components are. Its components, well, it went from 0 to negative 2, so this has a length of 2. I'm just keeping all positive values to get the length. This went from 3 to 5, so this also has a length of 2. So I'm going to do the inverse tan. Okay. Because I know I'm going to call this guy x right there. Okay, this little angle right here. So the inverse tan well, I'm going to say tan of x is equal to 2 over 2, or that x is equal to the inverse tan of 1, because 2 over 2 is 1. If I do that, you should already know that this is going to be 45 degrees. But 45 degrees isn't my angle. Okay, it's actually, I'm going all the way up to my vector. I want to go all the way up to the vector. Not the components, but the vector. So this angle, 45 degrees, isn't what I'm after. I'm after the rest of this. But if you recall, this whole thing would be 180. So my angle would be 180 minus 45 degrees, which equals, if we do it on my calculator, I think you get 135. Okay, so you go 180 minus 45, and you should get 135. And this is the angle because it comes from the positive x, so someone knows where they should be heading. Okay, when you do these ones here, just be aware of how this looks in terms of direction. Again, if it's pointing, it depends on how you draw it here, but if it's pointing, let's say I had one pointing like this, and I said, well, there's my angle. Suppose I found out this angle from dividing into components, okay, and I knew what x was. Well, I would subtract from 360. Okay, just be aware of what you're doing. If I solve for this as my angle instead, because I made this my components, okay, it's going to be the exact same because you're going to get a rectangle here. Say I made the x my angle. Well, it's not going to be 360 minus x. In fact, it'll be 270, because up to here is 270 plus x. 270 plus x will be the same answer as 360 minus this x. And again, these x's will be different. Okay, maybe call it x1, x2. They're going to be different angles here. So just be aware there of how to figure out the angle.